Hello, my name is Desmond Agboada, and I'll be presenting you my research today, titled Induction of LTP-like plasticity in the primary motor cortex with repeated anodal tDCS. tDCS is a non-invasive brain stimulation technique that induces polarity-dependent after effects, and in the primary motor cortex, there is an enhancement of cortical excitability with anodal tDCS and a diminution of cortical excitability with cathodal tDCS. It has been shown in one of the earliest tDCS studies that the after effects of tDCS can outlast the duration of stimulation. And with the right combination of parameters, tDCS can induce LTP-like plasticity in the brain. Recently, we systematically evaluated and titrated the parameter space of anodal tDCS with respect to stimulation intensity and duration. So we compared the 3 stimulation intensities and 3 durations with a sham to find the best stimulation protocol among this pool of protocols. And we found out that the intensified protocol of 3 mA per 20 minutes was the best among this pool. However, the after effects we observed were mostly still in the early LTP phase, so the time range was still a few hours post-stimulation. It's been suggested that to induce LTP, we will have to stimulate for a number of times within a specific interval. So space stimulation protocols have been shown to be superior to single stimulation protocols. This was shown back in the 60s with DC stimulation of the rat cortex. Binman and colleagues showed that application of 2 stimulation within a critical time interval increased the spontaneous firing in the rat cortex. To the best of my knowledge, this space stimulation technique was tried with tDCS in the motor cortex for the first time in the Montesilva study in 2013. Here they showed that stimulation with 1 milliampere in current intensity with a duration of 30 minutes enhanced cortical excitability for up to 60 minutes, which represents an early phase LTP-like plasticity. When the duration was doubled from 30 minutes to 26 minutes, there was a reversal of the polarity of after effects from an enhancement to a diminution. When a short interval was applied between the first and second stimulation, there was an enhancement of after effects, which lasted up to the next day evening. And here they used 2 different time frames of intervals to 3 minutes or 20 minutes, which are both short intervals in this research. So they were able to induce LTP-like plasticity with a short interval. But when the interval was increased to 3 hours or 24 hours, there was no enhancement of cortical excitability, which shows clearly that to induce a late phase LTP-like plasticity, the interval must be relatively short. So we built upon this by designing a study similar to that of Montesilva by trying to see if we can induce LTP-like plasticity with our recently developed intensified protocol, and we compare this with a standard anodal tDCS protocol of 1 milliamp per 15 minutes. We measured baseline excitability in the motor cortex with single pulse TMS-induced MEPs, and then we apply tDCS based on our design. So there's single session, and then there's 2 repeated sessions with a short interval repetition of 20 minutes or a long interval repetition of 3 hours. We measured after effects immediately after the stimulation every 5 minutes until 30 minutes, every 30 minutes until 2 hours, and then same day evening, next morning, next noon, and next evening. So the results showed that both the intensified protocol of 3 milliampere per 20 minutes and the standard protocol of 1 milliampere per 15 minutes enhance cortical excitability for half an hour. On the vertical axis, you can see the normalized MEPs, and then on horizontal axis, we epoch the duration of the after effects into 3 epochs. So 0 to 30 minutes, 60 to 120 minutes, same day evening to next day evening, to account for variability within the single time points post stimulation. Also, as you can see over here, even though both enhance cortical excitability within half an hour, the intensified protocol was slightly better. And we can see here that based on this time range, we could say that these two protocols were inducing early phase LTP-like plasticity. For the repeated session, the short interval repetition showed an enhancement of cortical excitability that lasted up to the next day evening for the standard protocol. So the standard protocol here was inducing late phase LTP-like plasticity. But for the intensified protocol, the after effects lasted only up to 2 hours, which is still in the range of early phase LTP-like plasticity. For the long interval repetition, both the standard and intensified protocol did not induce late phase LTP-like plasticity. The standard protocol increased cortical excitability slightly, whereas the intensified protocol showed a diminution of cortical excitability. The asterisk is a difference between the standard and the intensified protocols. So we propose some mechanisms for this observation. First, we suggested that based on the time frames, early single session anodal tDCS was inducing early phase LTP-like plasticity, whereas the short repetition interval induced late phase LTP-like plasticity for the standard but not for the intensified protocol. And this, we suggested, could be based on two plausible reasons. First, we suggested that induction of late phase LTP-like plasticity could be due to a synaptic tagging and capture. So according to this hypothesis, silent synapses are able to capture synaptic inducing proteins or synaptic tags from previously activated synapses and are able to use these captured tags to induce plasticity at their own synapses. But the half-life of these synaptic tags is 30 minutes. So we suggested that it could be that the short interval between the stimulation was efficient to recruit these synaptic tags for LLTP induction. And the reason why we could not find the intensified protocol inducing late phase effects could be because of calcium overflow. It's already been suggested that a higher intensity of stimulation produces more calcium compared to a lower intensity. So with more calcium at the synapse, it could be that this excess calcium was opening potassium channels and thereby causing a counterbalancing effect on plasticity induction. So in conclusion, we found that single session stimulation for both the standard and intensified protocols induce only ELTP-like plasticity. Repeated stimulation with a short interval resulted in LLTP-like plasticity for the standard protocol, but not for the intensified protocol. The longer repetition interval of 3 hours did not induce late phase plasticity for both the standard and intensified protocols. And this clearly shows that to use space stimulation protocols in the motor cortex, relatively short interval is preferable to the long intervals of repetition. And it also shows that when you're using space stimulation protocols, moderately strong protocols might be superior. So this paper has already been published and is now available online. I would like to thank my supervisor, Professor Michael Nietzsche, and then my colleagues in our lab here in Dortmund. Thank you so much for listening to this presentation, and I'll be happy to hear all your questions and your emails. Thank you very much.